Hi, meteorologist Paul Dorian here on Thursday, October 20th. It is time once again to take a look ahead at what kind of a winter it can be in the eastern U.S. and across the nation. We'll talk about many of the factors involved in this winter outlook over the next several minutes here. First, a programming note. The Peloton Weather YouTube channel has been transitioned to CTFV Weather. I will continue to provide the video discussions on day-to-day weather situations and as well as seasonal outlooks in the same manner as we're doing here today. Unfortunately, that CTFV is just a temporary name change. We will go to a permanent name change in the near term, and I'll certainly keep you posted. Well, I know this typically turns out to be a rather extended video discussion whenever we talk about a seasonal outlook, so I wanted to kind of talk about kind of the bottom line up front in terms of what to expect this winter season in the Mid-Atlantic region and across the nation before we get into the breakdown of all the factors involved. I do believe the overall winter will end up being slightly above normal in terms of temperatures in the Mid-Atlantic region. However, it is a bit more complicated than that. I believe there's a good chance of a quick start to the winter season with winter-like cold developing later in November and continuing into the month of December. In other words, this could turn out to be kind of a front-loaded type of winter for the Mid-Atlantic region. In terms of snowfall, as many of you may recall, last winter season was quite a different story in terms of snowfall amounts if you were north of the Pennsylvania-Maryland border. Many of the Philadelphia suburbs, for example, New York City metro region, ended up with above normal snowfall amounts, while places like D.C. far below normal in terms of snowfall. I do believe, once again, there could be a breakdown like that where north of the Pennsylvania-Maryland border, above normal snowfall is again possible. Places like Philly and its suburbs, New York and its suburbs, probably near normal in and around the D.C. metro region, a little bit less relative to normal south of the Mason-Dixon line. These are some of the numbers right here. By the way, all these maps that we'll go over today are right there on the posting on the weather website, which is still reachable, by the way, at peritonweather.com. But at the bottom of that posting, we have these numbers here, and again, maybe normal to slightly above normal temperatures for the Mid-Atlantic region, but a quick start. So that suggesting that late November and especially December could be below normal temperature-wise. That tells you that January, February, March could very well be warmer than normal in the Mid-Atlantic region. And here are some of the snowfall totals as depicted in the posting on the 2021-2022 winter outlook. Well, let's start off here by talking about some of the key factors involved with this year's winter outlook. First of all, I expect it will be another La Nina winter. What that refers to is the sea surface temperatures in the central and eastern part of the Pacific Ocean. Indeed, we had a La Nina winter last year, and it's not unusual at all for a first-year La Nina event to be followed by a second-year La Nina event. In fact, if you go back all the way to the middle of last century, to about 1950 or so, about 3/4 of La Nina events in one winter season were followed by another one in the subsequent winter, and that's what I expect to happen right now. Whenever I'm dealing with seasonal outlooks, looking ahead 2, 3, 4 months, first and foremost, I take a look at the sea surface temperature anomalies around the world at the current time, and also try to determine what can be expected during the upcoming winter season. In this case, weak to moderate La Nina conditions, very likely, in my opinion, across the central and eastern part of the Pacific Ocean, and we'll get into a further breakdown of that over the next few minutes. I also like to take a look at analog years, and by analog years I mean I go back into the past and try to find years that have similar overall environmental conditions to what we see today and what we expect to see over the next few months during the upcoming winter season. I used a strict threshold this year to classify, in my opinion, as an analog year. Namely, these three factors were considered in my selection of the analog years, of which I ended up with about 5, by the way. First of all, sea surface temperature anomalies. In this particular case, I had to, I only chose years that not only featured La Nina during the winter season, but featured a well-established La Nina that established back in the spring months of that particular given year. Also, I always like to take a look at the sun and what's going on in terms of solar activity, sunspots, and all that. So this particular upcoming winter season, I expect another year of low solar activity, much like last year. By the way, last year is one of my analog years of the 5 that I ended up selecting. So low solar activity had to be met in order to be classified as an analog year. And finally, the Atlantic Basin tropical season often is correlated with a quick start to winter or a late start to winter. So this season has certainly been an above normal and active year in the Atlantic Basin. So my analog years also had to have a lot of activity during the tropical season, in particular 15 storms, named storms or more. So again, a strict threshold on my part in my selection of analog years, and I ended up with 5, 3 of which relatively recent history. Finally, then I like to take a look at what are the prospects of what I call high latitude blocking, and that's an upper air pattern that generally features high pressure, higher than normal heights over places like Greenland, Iceland, northeastern Canada. It's all related to the polar vortex and the stratospheric warming. And the greater the chance of high latitude blocking, the greater the chance of some cold air outbreaks that will be sustained in the central part of the U.S. and the eastern part of the U.S. Any long-time resident of the Mid-Atlantic region and snow lover knows that you really have to have sustained cold air in order to get a good accumulating snowstorms along the I-95 corridor region, for example. And it's all related to high latitude blocking. So there are certain signals you can look at during the fall season, during autumn, that we'll talk about here over the next several minutes, that can give you a clue as to the likelihood for high latitude blocking. And specifically solar activity, the snowpack that's developing right now across the northern hemisphere, including, by the way, across the North Pole in places like Siberia, and the actual trends of some teleconnection indices known as the Arctic Oscillation and the North Atlantic Oscillation. We'll talk about all of these factors over the next several minutes. Well, let's take a look at the current sea surface temperature anomalies around the world. Again, this is first and foremost one of the factors I look at for a seasonal outlook. And look at all this blue. This horizontal line right here represents the position of the equator, 0 degrees latitude. The blue, colder than normal sea surface temperatures. This is the La Nina. And again, we had a La Nina established last winter season. It then tended to become neutralized or weakened during the spring and summer months of this year, 2021. However, lately it has been intensifying again and again. It's quite normal for a first-year La Nina event to be followed by a second-year La Nina event. That's what I expect to see this winter season, specifically a weak to moderate La Nina in this part of the equatorial Pacific Ocean, really ranging from the central all the way to the eastern part of the Pacific Ocean to the west coast of South America. So that is a crucial factor for the upcoming winter season, a weak to moderate La Nina in the Pacific Ocean. Notice also a lot of orange and red showing up in the Atlantic Basin. That represents warmer than normal sea surface temperatures. That too was in play last winter season, and I believe it will play a role this upcoming winter season. One of the big differences, however, from last winter is what's going on just south of Alaska, off the southern coast of Alaska. This little horseshoe-shaped below normal temperature pattern here in the northeastern part of the Pacific Ocean is quite different from what appeared last winter season. For several winters in this last decade, we've had a lot of warmer than normal waters just off the Alaskan coast, which has contributed to some warmer than normal winters there. That is looking quite different. Alaska could very well suffer through a colder than normal winter this season, and again, a horseshoe-shaped colder than normal temperature pattern sandwiched in between above normal sea surface temperatures. So we'll continue to monitor this tripole, as it can be called, in the northeastern part of the Pacific Ocean. So again, these are some of the factors involved with the winter outlook, and certainly something to monitor over the next several weeks. Well, let me show some of the supporting evidence of a La Nina this upcoming winter season, why I do believe there will be, in this case, a weak to moderate La Nina during the upcoming winter season. This is a map I've shown before. It's a compilation of numerous computer forecast models. Some are called dynamical, that feed in current conditions. Some are statistical models. And anything below this particular neutral line right here represents La Nina conditions. Anything above El Nino. And this is warmer than normal sea surface temperatures in this equatorial part of the Pacific Ocean. We're focused on the Pacific Ocean right here. It's a rolling 3-month average. This particular area right here represents the depiction by all of these computer forecast models in the December, January, and February time period in terms of average sea surface temperature anomaly. For example, right here, this is 1 degree Celsius below the normal, right across this horizontal line right here. So again, vast majority of these computer forecast models suggest La Nina conditions during the upcoming winter season. We're kind of a weak La Nina right now. Will intensify some over the next few weeks and likely fall in this particular area right here. I tend to believe more of a weak to moderate. Some of the models have a strong La Nina, including NOAA's own CFS V2. I'll show that next year, but I tend to believe a weak to moderate La Nina during the upcoming winter season. Well, here's the aforementioned NOAA CFS V2. This is their climate model of NOAA, and this is the forecast map by the very latest version of the CFS V2 climate model for December, January, and February in terms of sea surface temperature anomalies. They're suggesting, this model suggesting strong La Nina conditions right here across the equatorial part of the Pacific Ocean, all the way down into the darkest of blues. This is almost -2, -3 degrees below normal. That's a strong La Nina. I tend to think this is overemphasizing what will happen. It does agree with the overall sentiment of a La Nina in the Pacific Ocean. By the way, it also agrees with the overall sentiment of warmer than normal Atlantic and colder than normal right here in the northeastern part of the Pacific Ocean, with a warm blob sandwiched in between in this tripole region here. But don't think it'll get that quite drastic as a strong La Nina as depicted by this one model, but it's something to keep an eye on. And again, in summary, it agrees in general with all those computer forecast models that we saw in that compilation plot a moment ago. Well, this is another interesting plot I'd like to show here. Again, supporting the evidence, providing supporting evidence of a La Nina this upcoming winter season. Again, I'm really talking a lot about the Pacific Ocean because that's by far the biggest ocean. It has a huge impact around the world, not only in the winter season, but all around the year, throughout the summer months as well. This is the sea surface temperature anomalies at the surface and below the surface in the central part, the equatorial part of the Pacific Ocean. In other words, this right here represents the surface, and then you go lower and lower into the Pacific Ocean, the depths of the central Pacific Ocean, all the way down to 450 meters. And what we're seeing right now at the early to middle part of the month of October is a lot of cold water, colder than normal water just below the surface. This to me says La Nina is coming, because typically what happens this time of the year is this kind of cold air just beneath the surface bubbles up to the top. it bubbles up to the surface through what we call upwelling, that brings colder water from underneath all the way up to the surface. So when you see a lot of colder than normal water just below the surface in the equatorial part of the Pacific Ocean this time of the year, really suggests La Nina will not only continue into the winter season, but likely intensify over the next several weeks. So again, more evidence of La Nina this upcoming winter season. Well, of course, no winter season is exactly like another one, but there are typical patterns with La Nina winter seasons, and this particular plot reflects what can be expected in a normal La Nina winter season, and certain signals that are stronger than others in different parts of North America. First and foremost, typically you have a strong polar jet, such as reflected here by this arrow here. This is, as opposed to the subtropical jet, this is farther to the north during the winter season, and you often have colder than normal temperatures across Alaska, southwestern Canada, and all the way into the northern plains. This is a rather typical pattern of a La Nina winter season. And by the way, the colder than normal in Alaska kind of reflects what's going on with the sea surface temperature just off the Alaska southern coastline. So I do expect colder than normal conditions across the northern plains all the way out in the southwestern part of Canada. Also, you tend to have drier than normal conditions across the southern states, especially from Southern California to Texas to Florida. That too is in my forecast down there at the section at the bottom line, the bottom of the posting that's on the weather website right now. The Mid-Atlantic region, it tends to be kind of a mixed bag. We could go back to La Nina winters and see some warmer than normal winter seasons in a La Nina year, colder than normal, more snow than normal, less snow than normal. And nothing is set in stone with these common type maps like this. Last year, in the Mid-Atlantic region alone, we all experienced a La Nina winter, whether you were in D.C. or Philadelphia or New York City, but we ended up with more snow than normal. North of the Pennsylvania-Maryland border, as it turned out, it was a very accurate delineation of above normal snow to the north and below normal to the south. The D.C. airport, Reagan National Airport, for example, ended up with 5.4 inches of snow last winter season in the same La Nina winter that we all experienced in the Mid-Atlantic region, far below normal. But Philadelphia, all of its surrounding suburbs, New York City, all of its surrounding suburbs had well above normal snowfall, in some cases 40 plus inches just to the north and west of Philly, just to the north and west of New York City. So bottom line, no real strong signal in the Mid-Atlantic region for a La Nina winter, but relatively strong signal in terms of drier than normal across the southern states, especially from Southern California to Florida, and colder than normal in the northern plains all the way into the southwestern part of Canada and Alaska. Well, let's now get into the analog year discussion here. The reason I do this, I try to find years in the past that reflect similar environmental conditions to today and what I expect to see over the next few months. And take a look at what kind of temperature anomalies existed in those analog years when you average them together, and precipitation anomalies. Ended up with 5 particular years, again using kind of a strict threshold that A, they had to have low solar activity, which I expect to see this season. B, they had to have an active tropical season in the Atlantic Basin, which we had this particular year. In fact, many active Atlantic Basin tropical seasons are followed by a quick start to the winter in late November and December, and I indeed believe that will happen this year. Expect to see below normal temperatures, winter-like cold, perhaps later in the month of November, and especially during the month of December. We'll see how these analog years reflect that similar sentiment of a quick start to the winter season here. This is the average over the entire winter season of the temperature anomalies in the November to March time period. I expanded that all the way from November to March for these 5 analog years, and these are the 5 analog years I ended up with. Again, 3 recent history, including just last winter season, which had a La Nina, which had low solar activity, which also featured an active tropical season. the winter of 20 to 21, the winters of 54 to 55, 2007 to 8, 2010 to 11, and 2011 to 12 all had pretty similar sea surface temperature patterns as what we're seeing right now. And generally, in the eastern half of the nation, warmer than normal. In the western half, colder than normal. Again, I expect a quick start to the winter season in the mid-Atlantic region, perhaps with a colder than normal month of December, for example. But overall, when you look all the way through the month of March, probably ends up above normal in terms of temperatures, maybe just slightly above normal, but that tells you it could be kind of a front-loaded winter season with maybe a warmer than normal January, February, and March after a colder than normal December, maybe even November as well, and colder than normal in the western U.S. Well, in terms of precipitation anomalies for those 5 analog years, again, using a strict threshold, look at what's going on in the mid-Atlantic region when you average together those 5 years. Again, kind of a signal for, and part of the reason is we're including last winter season, but kind of a signal for below normal total precipitation south of the Mason-Dixon line. Of course, this is just an artificial geographical boundary, the Pennsylvania-Maryland border, but indeed sometimes it works out that the weather kind of behaves differently to the north versus to the south, above normal across upstate Pennsylvania, near normal in the southern part of Pennsylvania. Bottom line there, I expect in general nearly normal total precipitation amounts in the winter season when comparing to these 5 analog years, perhaps a little bit more to the north of the Pennsylvania-Maryland border and perhaps a little bit less to the south. And again, near to above normal snowfall amounts to the north, nearly normal maybe to the south of the Pennsylvania-Maryland border. Meanwhile, consistent with that typical La Nina winter season plot we showed earlier, drier than normal conditions across California, Texas, the southern part of the U.S., extending all the way into Florida. Definitely see this happening in Southern California. I'm not exactly sure about Northern California. Northern California may be different than Southern California during the upcoming winter season. We'll try to focus in on that more over the next several weeks. But certainly in this area right here, this is kind of a typical La Nina pattern from these 5 particular analog years. Expect basically drier than normal conditions across much of the southern U.S. Now let's take an interesting look at just the month of December for these 5 particular analog years, and look at this dramatic difference. A moment ago we showed for the entire winter season warmer than normal conditions in the eastern part of the U.S., and yet embedded in that November to March time period, the month of December by itself, colder than normal. No question there's a signal of colder than normal in the eastern half of the U.S. in these particular 5 analog years. And again, it's very critical how you select those analog years, and I gave you the threshold that I used, and I expect to see those conditions this upcoming winter season. But again, this suggests a quick start to the winter season. Colder than normal December is certainly on the table for the mid-Atlantic region and much of the eastern part of the nation. Well, here's the precipitation anomaly chart just for the month of December in those analog years, and you see above normal conditions or near normal in the mid-Atlantic region, the northeast U.S. So what this is telling us is that there's a decent chance of accumulating snow, in my opinion. Let's say between Thanksgiving and Christmas, we could very well have some snow cover. Places like Philadelphia, D.C., New York City on the ground before Christmas time. A quick start to the winter, perhaps turning out to be kind of a front-loaded winter season when you take an analysis into consideration of these particular 5 analog seasons. Well, let's now take a quick look at some of the factors involved with determining the prospects of high latitude blocking. Typically in a low solar activity winter season, you have frequent high latitude blocking events. And what I'm talking about is higher pressure than normal. Places like Greenland, northeastern Canada, Iceland, higher pressure than normal in those particular areas tend to favor cold air outbreaks that are sustained in the central U.S. and the eastern U.S., and that in turn increases the chance for snow. low solar activity right here, right now, as we begin solar cycle 25. I expect to see low solar activity throughout the upcoming winter season. That tends to be a more favorable prospect for high latitude blocking. Some empirical observations have shown that if there is a unusual buildup of snow in the autumn season, specifically in the month of October, that tends to be correlated with more frequent high latitude blocking, more frequent cold air outbreaks, and accumulating snow events in the eastern U.S. during the subsequent winter season. This is a snow map as of October 1st across the northern hemisphere. This is Siberia over here. This is October 1st, and this is what we see today by the middle part of October. Certainly it has increased some, especially north of the 60-degree latitude line in Asia, specifically northern part of Siberia. It has increased some, but it doesn't seem to me like it's anything out of the ordinary. So I guess all in all, the snowpack signals tends to be kind of, in my opinion, a neutral signal in terms of the prospects of high latitude blocking. Well, finally, I'd like to look at the recent trends in these two specific teleconnection indices, the Arctic Oscillation and North Atlantic Oscillation. They give us an idea of what the temperature and precipitation patterns are in the northern part of the Atlantic Ocean, and oftentimes what the trends are in the fall can translate into the winter season. So, for example, in the Arctic Oscillation, we've tended to be near neutral. The black line here, horizontal line here, right here, represents neutral conditions here. The Arctic Oscillation has been relatively close to neutral in recent weeks, going back to the early part of September. In fact, in the near term, in the future, this particular model from NOAA is depicting a positive AO. So I would say this by itself is just a neutral signal in terms of what it can tell us about high latitude blocking. North Atlantic Oscillation, on the other hand, has been largely in negative territory over the last several weeks. It looks like over the next couple of weeks it will be in negative territory as well. So the NAO, the trend of the NAO is more or less a favorable sign for high latitude blocking. So the combination of the solar activity, the snowpack, and the trends in the teleconnection indices tend to tell me that there will be some high latitude blocking events during the upcoming winter season. Perhaps not a blockbuster type of season, but enough cold air outbreaks that are sustained to produce some accumulating snow in the central and eastern states. Well, let's end up again with the bottom line here as summarized here up front in this particular video. And again, all of these maps and the text and right there on the homepage of the weather website, paratonweather.com. So you can go back certainly and take a look at some of these plots and maps and everything else that we've talked about during this video discussion. We'll certainly continue to monitor all of these factors over the next several weeks and as we head into the winter season of 2021 to 2022. That's it for now. I'm meteorologist Paul Dorian. Thanks for viewing.